based on these formulas, let us do some simple problems. So already in our previous lectures we have expressed some formulas for Faraday's laws. What does those Faraday's law states? Del cross E bar is equal to minus dou B by dou T. Like that we have derived 3 cases for Faraday's laws. Okay. Similarly, from the modified Ampere circuital law, del cross H bar is equal to conduction current density Jc plus displacement current density dou d bar by dou t. Like that some expressions we have derived. Okay. So based on this, let us do a small simple problem. They have given, consider a magnetic field with H bar is equal to 3x cos beta plus 6y sin alpha. Just a small mathematical expression, 3x cos beta plus 6y sin alpha into AZ bar. Find the current density. Find the current density if the field, find the current density if the field is time invariant. Okay. So what is the question that they are asking? Consider a magnetic field which is having a magnetic field intensity of H bar is equal to 3x cos beta plus 6y sin alpha into AZ bar. That means here only one unit vector is acting. In Cartesian system we are having AX, AY and AZ. AX and AY components are zeros and we are having only AZ component. Okay. So with this information, for magnetic field intensity H bar is equal to 3x cos beta plus 6y sin alpha AZ bar, they are asking you to find the current density if the field is time invariant. Actually we are studying the time varying fields unit, but for this problem they have given that the field is time invariant. So with this information, how you can find the current density, the relation between magnetic field intensity H bar and current density means we will denote it with J bar. So what is the formula which will link with this H bar and J bar? The formula that is linking this H bar and J bar is, here we can clearly see that del cross H bar is equal to Jc bar plus Jd bar, that is dou d bar by dou t. Okay. Del cross H bar is equal to conduction current density Jc bar plus displacement current density, that is dou d bar by dou t. But here what is the information they have given? The information is that field is time invariant. The field is time invariant means that quantity is not varying with respect to time. Not varying means any differential quantity dou d bar by dou t, that will become equal to 0. Time invariant means your field is constant. What is the derivative of a constant? The derivation of constant is equal to 0. So what is the final equation that you are left out with? Del cross H bar is equal to J bar. Del cross H bar is equal to J bar. That means if I want to find the current density J bar, then simply what you can do, del cross H bar, if you find the cross product between the del operator and H bar operator, that is they have given that value, then that will result you in current density J bar. So let us solve this cross product so that we can find the current density J bar. Okay. So to find this cross product del cross H bar, which will yield you the result current density J bar, so your current density J bar can be obtained with the formula del cross H bar. Now I am finding this cross product del cross H bar. So during this cross product we are using Cartesian system. So what are the unit vectors in Cartesian system? Ax, Ay and Az. Okay, so next we are having del operator means already in our first unit we have defined del operator means dou by dou x of something plus dou by dou y of something plus dou by dou z of something. So I am writing dou by dou x, dou by dou y, next dou by dou z. Okay, dou by dou z. And here for this magnetic field intensity h bar, what is the value that they have given? For this magnetic field intensity h bar, the value that they have given is 3x cos beta plus 6y sin alpha into Az bar. In this h bar, we are not having any Ax component or Ay component. So Ax component is 0, Ay component is 0. The only component that you are having is Az component, which is equal to 3x cos beta plus 6y sin alpha. So can we find the determinant value for this? If we find the determinant value for this, so leave this first term, so Ax bar into, leave this row and this column, dou by of 3x cos beta plus 6y sin alpha. Okay, so for finding the determinant of this, we should find Ax into dou by dou y of this term and minus 0 you are having, because this term will become 0, and after that minus Ay into, leave this row and this column, dou by dou x of 3x cos beta plus 6y sin alpha. Again minus 0, you will be having 0 into this term will be 0. So after solving this determinant, del cross h bar is equal to current density J bar, because from modified Ampere circuital law we are having del cross h bar is equal to conduction current density Jc plus dou d by dou t, that is displacement current density. Now as your field is time invariant field, we can write dou d bar by dou t is equal to 0. So the equation is becoming del cross h bar is equal to J bar. Now your cross product already we have obtained. If you solve this value, we can get the value of del cross h bar, which is nothing but equal to the current density J bar. So after finding these partial derivatives with respect to y, so for x term, if you are partially derivating with respect to y, that will become 0, and for y term, if you are partially derivating with respect to x, that term will be also 0. Only up to here this y term is valid, and here this x term is valid. So after solving, you will get 6 sin alpha, because partial derivative of 6y sin alpha is with respect to y with respect to y means 1. So 6 sin alpha, this term partial derivative will become 0. And what about the other term? Into Ax bar minus 3 cos beta into, what is the unit vector? Ay bar. So this is the current density. What is the unit of the current density? General formula for current density is current divided by area. Current divided by area means, current means amperes, per area means meter square. So this is your final answer. So they have given you the magnetic field intensity h bar in Cartesian system, and they are asking you to find the current density J bar if the field is time invariant. Okay, so the formula is del cross h bar is equal to J bar. So del cross h bar cross product we have calculated, that is equal to the current density J bar, which is, this is your final answer for current density. So let us see another problem. They have given that for a dielectric material, the conduction current density Jc bar is equal to 0.02 sin 10 power 90 amperes per meter square. Okay, conduction current density Jc bar is given, and they have also given sigma value, that means conductivity value, as 10 cube Siemens per meter. Okay, so we already know that conduction current density formula is Jc bar equal to sigma into E bar. So here they have given you the sigma value and conduction current density value, that is Jc is given as 0.02 sine 10 power 90 amperes per meter square, and sigma conductivity is given as 10 cube Siemens per meter square. Now, and also they have given epsilon r, that means relative permittivity as 6.5. Relative permittivity value is 6.5. With this information they are asking you to find the displacement current density. Displacement current density, that means JD bar. They have given you the JC bar, and that means conduction current density value, and they are asking you to find the displacement current density JD bar value. Okay, so with the given data, JC value are already having, sigma conductivity are already having, epsilon r value they gave, and finally what is the relation between JC and JD? We already know that JC bar by JD bar is equal to sigma by omega into epsilon. JC bar by JD bar is equal to sigma by omega into epsilon. So from this, what is displacement current density JD bar? JD bar, if you send it that side, what will happen? So omega epsilon into JC bar by sigma. Okay, omega epsilon JC bar by sigma, where you know all the values. We know that epsilon is equal to epsilon naught into epsilon r. What is the value of epsilon naught? That is 8.85 into 10 power minus 12 farads per meter, and epsilon r value they have given you as 6.5, and JC value also they have given you. JC and sigma value they have given you. So from that you can find the value of displacement current density JD bar. If you compare this equation, general equation format is E equal to Em sine omega t. Okay, if you compare this equation JC bar is equal to some constant 0.02 into sine 10 power 9 t. That means in the place of omega, what you are having? In the place of omega you are having 10 power 9. So your displacement current density JD bar is equal to omega means 10 power 9 into, what is epsilon? Epsilon formula is epsilon naught into epsilon r. That means epsilon naught is 8.85 into 10 power minus 12 into epsilon r value they have given in the question as 6.5 into, what is JC value? Conduction current density magnitude is 0.02 divided by what is the sigma value they have given you? 10 cube. Okay, sigma value, conductivity value is 10 cube. So on substituting and solving all these values, finally we'll get displacement current density as 1.151 amperes per meter square. If you express in sine or cosine forms, JD bar can be written as 1.151 into cos 10 power 9 t ampere per meter square. Okay, you can express conduction current density JC bar in terms of sine, and you can express JD bar in terms of cos. Already omega t value they have given 10 power 9. Just we have calculated the value of magnitude only. That magnitude is equal to 1.151, which is obtained by this procedure. Okay, so these are some basic problems on displacement current, conduction current, displacement current density and conduction current density. Next our topic is about Maxwell's equations. With these Maxwell's equations, maximum your 5th unit will be completed.